store, which goes from 1% solution to 3%. This is 30%. So it's very, very strong. If I didn't have gloves on, it could burn my skin badly. So this one's pretty strong. I'm just going to put a little bit of it into my graduated cylinder. And then I'm going to add some soap bubbles. Ooh. Or we're going to pour that down the sink with lots of water and try again. I'm going to get new gloves too. Slippery here today. Okay. Try this again. There we go. Now I'm going to try and add some soap bubbles. They're just an indicator because soap bubbles trap gas. So if we create a lot of bubbles, we know we had a lot of gas. If we create a little bubbles, we know we had a little bit of gas. If we get no bubbles, we didn't have a gas. And then I'm going to use potassium iodide. If you look at my reaction up here, is potassium iodide a reactant?
No, it's a catalyst.
It's a catalyst. So should it be used up in this reaction? No. In fact, iodine, when it gets wet, it's yellowish in color. So you'll probably see a yellow residue, letting us know it wasn't really used up in the reaction. It is left over from the reaction. Okay, can you guys predict what your products should be from this reaction?
H2.
I'm hearing what? Water and oxygen? That would be a possibility. What's our other possibility?
Hydrogen and oxygen.
Hydrogen and oxygen. Okay. And what type of reaction is it?
Decomp.
Decomp. So let's see what we get. What's the steam? This is heat. You can actually feel it. If you come a little bit closer, it's very, 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 very hot because all those bonds just got broken and it was released a lot of energy. What are we left over with?
Gas.
Yeah. Did you see any liquid?
No.
Not very much. So what do you think most of our products are?
Hydrogen and oxygen.
Yeah. H2 gas and O2 gas.
Can we do that again?
Now, as it cools, you'll have bonds forming and it'll go back into some water. Gas released to the atmosphere and then we'll have water. Okay. There's that one. You like that? That's one of my favorite. I've done it since the first year I taught, and last week when I went to the doctor's, I had a male nurse, and he happened to have been a student in my first physical science class ever, and he remembered that reaction.
Oh, that's weird.
That was really weird. So when your students are nurse, it's like, okay, that's kind of weird. I know too much about you for you to be my nurse.
Don't stick that in.
Okay, now we're going to use sodium. Sodium is very, very high on the metal scale. It's highly metallic. We store it in gravel and oil because it's highly reactive with the air and water, as you'll see here in a minute. So we don't just leave this laying around because we'll blow up the building, quite honestly. So it is packed in oil, and I'm going to pull a piece of it out of here. It's easier for me to get with my hands, so I'm just going to put that out there. And what I'm going to do, don't worry, it's covered with oil, as you can tell, so it's not real reactive for us right now. Okay, and I'm going to cut off a piece. When I cut that off, notice how shiny it got? You can see how it's just really shiny now. That shows the luster and the shiny characteristics of a metal. But as it's exposed to air, it'll very quickly turn whitish, and it's more clay-like in texture. It's kind of like Play-Doh. Not that I should let my kid play with it, as you'll see why here in just a second. Okay, we're going to put the rest of that back safely and out of the way. And I'm going to take this piece of sodium, and I'm going to attempt to remove the oil now so that we can get it to react when we do this reaction. The more oil I'm able to squeeze out of it, the more reactive it's going to be. Also notice as I'm doing this, I'm actually forming it in a ball. It's very, very clay-like. It's very, very soft, which is not what you think of because most metals we're exposed to are hard metals. Very strong metals are very soft and clay-like. And also highly reactive, which is why we're not exposed to them very much. Still got a little oil on there, so we're going to squeeze it some more. this reaction. What type of reaction do you think this one is?
A single replacement.
Okay, single replacement. I've had some students look at it and think maybe a synthesis. What makes you think it's a single replacement over a synthesis? Right, you have a single element in a binary compound. That single element is a metal. So it could sodium replace hydrogen? Okay, so you can kind of think about what these products are going to be. Move this out of the way. Will you turn both lights out for me real quick? Yep. And I'm just going to take this piece of sodium, get the lights out, and I'm going to throw it in the speaker.
Ooh.
Watch it. What are you hearing?
Sizzling sound.
What's that an indicator of? Oh, you got a good one. This one's really on fire, you guys. Oh, gross. You got a good one. Okay? I'm fine. Now you know how to use the skill. Oh my